episode in our STEM virtual experiment series. I am Xavier Murray, a Technical Information Officer of the Scientific Research Council. With me is the exuberant Essence Calendar.
Hi.
Today, Essence will be assisting me in investigating the electrical conductivity of ionic and covalent bonds. Essence, what do you recall of the structure of an atom?
The structure of an atom consists of protons, neutrons, and electrons. Protons are positively charged, neutrons have no charge, and electrons are negatively charged.
Excellent. The electrons are of particular importance because once the outer shell, the valence shell, reaches 8 electrons, the atom is said to be stable. And atoms will always try to achieve that level of stability. This is known as the octet rule, and this is accredited to Richard Abegg and Gilbert Lewis. Last question. How would you define electricity?
Electricity is the flow of charged particles.
Excellent. Again, either positive or negatively charged particles both allow the flow of electricity. To investigate this, we're going to create a simple circuit using LED lights, C-cell batteries, electrical tape, and copper wires. After which we will investigate salt, sugar, vegetable oil, and potassium iodide to see which of these compounds can conduct electricity. Essence, which of these compounds do you think will be able to conduct electricity?
I believe that potassium iodide and salt will conduct electricity.
All right, we have our prediction, so let us carry out the experiment to see if she is right or wrong. Essence, we'll start by using the wire cutters to extract one of the LEDs on the string of LEDs. Then she's going to strip the ends of the LEDs using the wire cutters. And then using your copper wire, you're going to cut this. And once again, she's going to strip both ends of the copper wire. Right? And then we're going to use electrical tape to tape all our batteries together. Or we just need 2 actually. So let's use 3 just to make sure. She will now affix the copper wire to both ends of the LED. So lastly, we're going to use some electrical tape just to fix the copper wires onto the terminals of the battery. This side to this side. All right, so we'll check our circuit to ensure the theory is correct. Aluminum is electrically conductive, so when both ends touch the foil, the light should illuminate. Our apparatus is working correctly, and we can go ahead and test the other household materials. Let's start with salt. It's apparently incorrect, but we'll do another experiment with salt. Let's try sugar. Also nothing. All right, so let's try one more experiment. We're going to dilute, or we're going to dissolve salt and sugar in water, and then run the same experiment again. So we're going to dissolve sugar in some distilled water. Essence, if you may. And it does not conduct electricity. So let's try the salt. Remember that in the solid form, salt did not conduct electricity. We'll try it in aqueous solution. Essence, if you may. Alright, so this time it conducts electricity. Essence, do you have any hypotheses or any theories as to why salt is able to conduct electricity in water.
The solution has ions, and ions are charged particles.
And why was it able to do it in water when in a solid state it is not able to conduct electricity?
Well, in the water it can move freely.
Right, and recall we said earlier that electricity is the flow of charged particles. So in a solid state, the particles cannot move. But once you put it in a liquid or an aqueous solution, they're able to move, able to flow, and thus able to carry an electric current. All right, so we're going to finish up with potassium iodide and vegetable oil. Nothing. So vegetable oil is not electrically conductive. This time we'll try potassium iodide. And lo and behold, essence is actually correct. 2 for 2. Potassium iodide and salt are able to conduct electricity once in aqueous solution. And that is our experiment on the electrical conductivity of ionic and covalent compounds. I would like to thank the Exuberant Essence Calendar for being our guide today. And remember that we use common household items, so you can do this experiment under adult supervision with various items in your own household or other items if you want to investigate the properties of those compounds.
It was my pleasure to assist. Don't forget to like, share, and subscribe to our YouTube channel.
And tune in next time for another episode in our STEM virtual experiment series. Bye.
Bye.